This is Brody.
I'm Will.
And this is Noah. And this is Jack. Angle, side, side.
We have a prank being set up for my little brother. We're gonna pretend like Noah's injured and have my little brother come down and run super fast to help. And he's gonna trip over the saran wrap through the doorway, and when he does, we're gonna pie him in the face.
So we had to add a little bit of weight here. So when he runs through, he doesn't just rip through it, or just take it off the wall. Ow!
No, it's okay, dude. Come on, it's okay.
Ow!
Come on, hustle. Dude, this was a new shirt.
Wait.
Rock, paper, scissors. Loser gets water ballooned. What?
So first, to solve the equation, we need to start with the equation for the volume of a sphere, and that equation is volume equals 4/3 pi r cubed. So then we have to take the derivative of the formula for the volume of the sphere with respect to time. And so when you take the derivative of v, you get 1, but then 1 times the derivative of volume with respect to time, or the change in volume over the change in time. And then when you take the derivative of this, you get this chunk, because this 3 times 4/3 becomes 4, and then you lower the power by 1, and then we also have to add the change in radius over the change in time on that. And so now we are going to use the values of the balloon is filling up at a rate of 128 cubic centimeters per minute. So the volume is changing at that rate. And then we're looking for how fast the radius is changing when the radius is at 4 centimeters. So now we can plug in the 128 and the 4 into this equation. And now we have 128 equals 4 pi times 4 squared times the derivative of the radius with respect to time. So now, after we plug this in, we can simplify it to get, so this is 16 times 4 is 64. So we now have 64 pi times dr over dt equals 128, but we still need to solve for the, at what rate the radius is changing when the radius is 4. So we have to divide 128 by 64 pi to get the rate that the radius is changing at. So now when we plug this into our calculator, we get 0.637 equals dr over dt. So that means that the radius is changing at 0.637 centimeters per second when the radius is 4. This is what you get when you lose rock, paper, scissors.
Okay, get it. Ready? Tell me when.
No.
You didn't get it.